Hey guys, my name is Shreyas and welcome to Simple Chemistry. Today we're going to be talking about classical names for ions. So what does that mean? Sometimes scientists use names rather than Roman numerals for transition metal ions. So basically we've been doing this for metals which are not in these two columns and which are not silver, cadmium, zinc, or aluminum. We've been using Roman numerals to identify the oxidation states whenever we're writing the names for compounds which have these metals, okay? And we've been just using Roman numerals, right? But sometimes, for some elements, scientists like to use what are called classical names for the ions rather than the Roman numeral name, okay? And that happens for some certain number of elements right here. So for these four elements, chromium, manganese, iron, and cobalt, can either have a +2 or a +3 oxidation state whenever they're in a compound, either a +2 or a +3 oxidation state. Okay, that's why I like to call them the +2 or +3 group. So whenever we see chromium 2 in a compound, we can call it chromous. Chromium 3 is chromic. Manganese 2 is manganous. Manganese 3 is manganic. Iron 2 is ferrous. Iron 3 is ferric. Cobalt 2 is cobaltous. And cobalt 3 is cobaltic. Okay, these are the classical names right here. That's the first group. Now for copper, copper in a compound can either have a +1 or a +2 oxidation state. So copper 1, the classical name is cuprous, and copper 2, the oxidation name is cupric. Now I just want to stop right here and take a pause. This is not going to be tested on the AP exam. So if you're just watching this video just to review for the AP test, go ahead and skip this lesson because this will not be tested on the AP exam. However, if you're a student in general chemistry in college and your professor required you to learn this, or even if you're in high school and your teacher required you to learn this, this will benefit you because sometimes when we're looking at stock chemicals, like if you're in a lab and we're looking for compounds, the labels for these compounds will not have the Roman numeral name. They will have the classical name for that compound. So it is important to know this. But if you're just reviewing for the AP test, you'll be wasting your time memorizing all these classical names, so go ahead and skip it. But if you're not, I would highly recommend you keep watching. Okay, so that's the +1 or +2 group. Now, the +2 and +4 group, that's for tin and lead. Tin and lead can either have two oxidation states, +2 or +4. So for tin 2, the classical name is stannous. Tin 4 is stannic. Lead 2 is plumbous, and lead 4 is plumbic. All right? And mercury is a little weird. The mercury ion can exist in two forms, Hg2+, and that is mercury 1, or just Hg2+, and that's mercury 2. And this ion, is the classical name for it is mercurous, and then this ion, the classical name for it is mercuric. Now let's go ahead and do a few examples of naming compounds, except now we're going to be using classical names for the ions instead of regular Roman numeral names. So here we have a binary ionic compound because we have a metal and a non-metal. Copper is a metal because it's to the left side of the periodic table. Chlorine is a non-metal because it's to the right side of the periodic table, the zigzag line, right? Okay, so this is a binary ionic compound. Now let's go ahead and look at the oxidation states, label the oxidation states for these the elements within this compound. So we know chlorine is going to have a -1 charge because it's in this row. Why do I keep saying that? This column of the periodic table. Sorry, excuse me. So it has a -1 charge. In order to balance out the charge for the compound to be neutral, the copper must have a +1 charge. So the oxidation state of the copper is +1. If this makes no sense, what I just did here, go watch the video on oxidation states in the previous, I think it's in the previous unit. I will link it in the description. But so we have copper having a +1 oxidation state. Now, if you wanted to name this compound using our regular ways of naming them, we'd just say copper 1 with the Roman numeral chloride. But instead of saying that, we can instead name it as cuprous chloride. So let me write that down for you. Cuprous chloride. Okay, pretty simple. Let's look at the next example here. Oh my gosh. Just trying to make myself a little bit more room. Okay, so cuprous chloride. Next example here is SnO2. This also is a binary ionic compound because we have SN tin, which is to the left side of the zigzag line. So we have a metal, and then we have oxygen, O2, that O2, which is a nonmetal. Metal plus nonmetal is a binary ionic compound. Let's go ahead and look at the oxidation states here. Let's figure out the oxidation states. So oxygen has a -2 charge, oxidation number, always, because it's in this column of the periodic table. And then since there's 2 oxygens, the overall negative charge is -4. In order to balance that out, the tin needs to have a +4 charge. Since there's only one tin, +4 divided by 1 is just +4. So the tin has a +4 oxidation number, okay? Now, if we wanted to name this using our regular rules, we just call this compound tin 4 oxide. But instead, we can use our classical name and call it stannic oxide. So let me write that down for you. Stannic oxide. All right, let's look at our next example here. We have a ternary salt here because we have a metal, a mercury. Mercury is a metal because it's onto the left. It's the left side, on the left side of the zigzag line, and we have a polyatomic ion. So metal plus polyatomic ion is a ternary salt. This polyatomic ion here, CO3, is carbonate. So let's go ahead and figure out the oxidation number for the oxidation state, or for this mercury right here. So let me do this again. Oh my god, it's so hard to just select. Okay, there, I got it. So we have Hg2CO3. The carbonate polyatomic ion has a -2 charge, so its oxidation number, the polyatomic ion, is -2, which means there has to be a +2 charge to balance that out. Since there's 2 mercuries, +2 divided by 2 is +1. So each mercury has a +1 charge. So if you wanted to name this compound right here, we just say mercury 1 carbonate. But since we have a classical name for it, we can also name it as mercurous carbonate. Let me write that down for you. I'm going to write it down here. Mercurous carbonate. Okay. Now we've discussed this. Now let's go backwards, okay? We have the classical name for the ion. Now let's figure out what the actual chemical formula is. So here we have ferric hydroxide. All right, so ferric, if you look here, ferric means we have, ferric means we have iron 3, or just Fe3+. So we have iron, with a +3 charge, and then we have hydroxide, which with a -1 charge. So in order to just balance the charges out, we need to just flip the numbers. So -1 charge right here, there's only 1 iron. +3 charge right here, there's going to be 3 hydroxides. Okay, and ferric hydroxide is just FeOH3. Good. All right. Now let's go to our next example here. Stannous phosphate. Stannous, if you look here, stannous is for the +2 tin. Okay, tin 2. So we're going to have tin having a +2 charge, and then we have phosphate. which is PO4 3 minus. So we have PO4 and it has a minus 3 charge. Okay, so we just flip the numbers. So phosphate is 2 and tin is 3. So stannous phosphate is SN3 PO4 2. Final example here, we have mercurous nitrate. Mercurous is Hg2 2 plus. Okay, it's Hg2 2 plus. It is not Hg1 plus, it's Hg2 2 plus. Okay, make sure you understand that. So we have Hg2, we have, right here, Hg2, and this has a plus 2 charge. And then we have nitrate, which has a minus 1 charge. So what we basically do is we leave the Hg2 like this, and then the nitrate, there'll be 2, just flip. So Hg2 NO3 2 is mercurous nitrate. Okay, so that's what classical ions are. And again, if you're, this is going to probably take some studying, but if you're just reviewing for the AP test, please do not waste your time memorizing this. Move on, because there's more important things you need to know than this, because this will not be tested on the AP test. But that's it for now. Classical names for ions is as simple as that.